Squeeze theorem. You're still going to get 15 minutes to work on your homework. Don't worry. Stand up, run around the room for a minute or two. So this is not going to take that long. Squeeze theorem. Talk about it on page 65. Page 65 in your book. This is the tip of the iceberg on the squeeze theorem. Okay, tip of the iceberg. So we don't really have to do much on it. But let's say I wanted to find the limit as x goes to 0 of some crazy function like x times the sine of 1 over x. Okay, which you try to do substitution, and here's what happens. You plug 0 in for x, you get 0 times the sine of 1 over 0. Well, 1 over 0 is undefined, and as far as I know, I can't take the sine of undefined angles. So I have 0 times undefined, which is also an indeterminate form. Okay, it's also an indeterminate form. Okay, so that just means I need to try to do this a different way. Problem is that there's no algebra I can do to this. Okay, I could make a table of values. Okay, I could look at a graph, but there's something else that they like to use here, and that's something called the squeeze theorem. And what the squeeze theorem does is it takes this function, its graph, okay, so let's call this function f of x. So I'm trying to find the limit as x goes to 0 of f of x. That's what I want to find, but I can't. It's indeterminate. I can't do any algebra. So here's what we're going to do. We are going to squeeze this function, f of x, in between two other functions. We're going to call them h of x and g of x. And h of x and g of x are two other functions that you make up. Now the good news is that you don't have to make them up. They're actually given to you, okay? But this function has to actually physically, its graph has to be less than or underneath g of x, and it has to be above h of x. So this means that f of x's graph is in the middle of h of x and g of x. And like I said, in the real application of this, you would have to make up your own functions or come up with your own functions that do that. Okay, so first of all, you have to have this. So if this is the case with your functions, okay, so again, I've graphed this function in the middle, and then I have these two functions. This is the negative absolute value of x, which you should have known what that looked like. It's a v going down. The positive absolute value of x is the v going up. Would you agree that this function's graph is squeezed right in the middle of those two? Okay, what is the limit as x goes to 0 of negative absolute value of x? Can you use direct substitution? It is 0, okay, equals 0. And this one, the limit as x goes to 0 of absolute value of x is also 0. They are the same. And would you agree, looking at the graph, that this function is squeezed directly in the middle of those two? And they both have the same limit? So what can you say the limit as x goes to 0 of x sine of 1 over x is?
0.
And that's the squeeze theorem. So you have one problem like this on your homework.